Many of you brainstorm inside Claude Desktop because it is pretty good. It writes clearly and gives you a solid plan. What I usually do is take that plan and go back and forth between different tools. But then this problem comes up. They do not have any shared context. For example, if you are working on a single project and make a change in one place, then go to another tool and ask something that depends on that change, it just does not know. There is no awareness of what happened elsewhere, no shared memory. But what if I told you that all these clients, especially MCP clients, could have one shared memory block? That is what I am going to show you today. You've probably heard about Mem0, which was a memory layer for AI agents, and it turned out to be really impressive. It was featured on many channels, and a lot of people praised how powerful it made their agents. Now they've released a pretty cool tool called OpenMemory. It basically gives you a single memory, which you can think of as a memory chip that works across all your MCP clients. It connects all your memory clients together into one continuous memory space. Right now you can use it locally, and it's also designed for cloud use, which means you will not need to install anything. Your memories will be stored on the cloud if you choose, although both options are fully supported. Okay, so this is the OpenMemory GitHub folder, and you can see that OpenMemory is actually inside Mem0 because Mem0 is the main repository. In order to get OpenMemory, we're going to have to clone the entire Mem0 repository. What you're going to do is go back to the Mem0 repository, get the link, copy it, then open your terminal and type git clone followed by the GitHub repository link. Once that's done, you'll go inside that repository, and inside the Mem0 folder, you're going to find the OpenMemory folder. You'll then navigate into that, and all further commands will happen from there. If you scroll down, you'll see that to quick start, you need to run these commands, which are basically make files that set up the dependencies. You'll need to run the UI and the MCP server. First things first, Docker needs to be up and running on your system because it downloads and sets up Docker containers along with the dependencies. To do this, just run the make build command, which installs those containers. After that, run makeup, which starts the containers. Keep in mind that you only need to run make build once to build the containers. Later, when you want to use it again, just run makeup. Also, whenever you want to use the MCP server, Docker must be up and running on your system. Until you get access to the cloud, you'll need to keep Docker running to use it locally. Now in the other tab, you can see that the MCP server is currently running. If I go back, you can see that the OpenMemory MCP server is now up and running. Let me show you it's currently running on localhost 3000, which is what we want. That's the address where the UI runs. So if you want to track the UI, navigate to that address. One more thing I forgot to mention, you need to open this directory in Cursor. Once you open it, it'll look something like this, and the file structure will appear like this. Inside the file structure, go to the API folder. In there, you'll find a .env example file. You need to paste your OpenAPI key into this file. Copy it, rename it to .env by removing the word example from the file name, and then paste your actual API key into it. Once that's done, you'll be able to use the makeup command. They've listed this step as a prerequisite because it's required for LLM interactions, which is why they ask for the OpenAPI key. Okay, you can see that now that the app is open again, we need to install the MCP for different tools. We have the MCP link, which you have to manually configure in the settings. The MCP configuration lets you accept it manually. Or what I really like is the set of pre-built commands they provide. For example, if I write a command, you'll see the one they've given. When you run it, it automatically adds the MCP to the Claude client for you. The same applies to Cursor. I'll just set it for Climb or whatever you want to use, and it handles it for you. Let me show you. You can see that I installed both of these MCPs. Here I installed it for Claude, and down here I installed it for Cursor. Now if I go back, for example, you can see that in Cursor, it's already up and running. And if you check Claude 2, you'll see that Claude connected to the MCP server name I assigned. It's also present, and both are connected to this server running locally on the system. Let's look at what the OpenMemory MCP has to offer. On the website, they've listed a lot of features, and we can see them right here. For example, you can personalize your interactions with your preferences saved in memory. Then there are supported clients. Besides the ones shown, others can be added too. You also get full memory control, including the ability to define retention and even pause memories if you want. As I told you, if you want to use it with the cloud platform, you should go ahead and sign up for the waitlist. They've listed a bunch of use cases too. Beyond that, it's mostly standard information. If you're enjoying the video, I'd really appreciate it if you could subscribe to the channel. We're aiming to reach 25,000 subscribers by the end of this month, and your support genuinely helps. We share videos like this 3 times a week, so there is always something new and useful for for you to explore. This is an example of how you can actually use the MCP server. What I did was open Claude Desktop and asked it to brainstorm an idea for a time tracking app. First, it gave me its own plan. Then I added my follow-up points, things I thought should be implemented. After it integrated my changes into the original plan, I asked it to add the plan to memory as time track plan. I didn't know exactly how that worked at first, but it turns out you can't add full plans directly to memory. What actually happens is, let me just open the MCP for you. It takes the whole text as input. And remember, we input the OpenAI key earlier. That's used to break the input down into smaller tasks automatically. For example, I opened this plan here, and although other tasks had also been added, I think about 10 tasks were extracted from this single plan. You can see it's broken into different plans and categories. Now you might be thinking all these plans are scattered, but don't worry. I'll explain later how they've actually grouped the prompts. I didn't notice it at first either, but eventually I saw that they were being grouped together. I actually figured out the method they used, and I'll explain that part soon. Moving on to Cursor, I gave it a prompt saying I want to build a time track app and asked if it could pull the details from memory. It then used the MCP tools to list and search the memory. This part is really useful. It searches relevant information. So when it queried about the time track app, it retrieved memories related to that. From there, it pulled details about Next.js, React, TypeScript, and the rest of the stack we'd be using. It started building. After it finished, I asked it to save its progress to memory, and it did. It added those progress notes, broke everything into chunks, and stored that too. So now all those updates were saved in memory. Let me actually show you the app. This is the app that was created. There were a few small changes, and I'll also show how memory helped with that. After a while, Cursor gave me an error when starting a new chat because of context size. Once I did start a new chat, I asked it to retrieve memories related to the app's progress. It called the MCP tool again and retrieved all the relevant data, like where it was running and what it had done so far. Then I had to give it a screenshot because the contrast in some React elements was bad and the text wasn't visible. I asked it to fix the UI a bit. While it was doing that, it kept calling itself again and again, trying to locate the source directory, but it didn't know there was a front-end folder. So I thought I'd try giving the full directory structure in memory. After it fixed the issue I asked about, it listed the whole directory structure in text form and returned that to me. But that part didn't work. It ended up returning an empty result. So I think only plain text gets saved properly. That kind of structural info wasn't understood or saved by the LLM. I also got some other UI fixes done, and eventually the app was finished. It's working completely now. Let me just add an entry. Let's say we're working on something, and here's the date, March 3rd, 2015. You can see it was added. There are still a few UI issues, but nothing major. They can be fixed easily. Now, what I want to show you is how it actually retrieves the memories. Before that, you can also see the source app for each memory, like some were created by Cursor, others by Claude. If we open up memory, you can see the access log. You can change the status or even edit the memory itself. For example, I could paste the directory structure here too. I'll try that out and see if it works. But the main thing I want to show is this. This memory is linked to all the other memories created in the same session. So if the MCP client requests one memory labeled time, it also fetches related memories. That's how they're grouped. I figured this out while checking the search calls. When it searched for time tracking app, it also pulled in context about other related functions. So that's where all these came from. Right now, it's actually really good. Memory is consistent across sessions. My local MCP's client can access it, and even the MCP agents built with MCPUs can access it. That's also pretty good. You can see right here that I wanted to build a to-do list app. At first, I used the same tech stack just to test how it would perform compared to another project. But then I thought, why not change it up and properly test if it can differentiate between different projects? So I told it that we'd be using the MERN stack, and then I asked Claude Desktop to push that to the MCP server. After that, I went into Cursor and asked it which tech stack we'd be using for the project, while also telling it to only use the MCP and not check the directory. It made the MCP call, but it got totally confused. It said we'd be using both the MERN stack and Next.js. Basically, it pulled in the stack from the previous project and this new one. Both got uploaded and it retrieved them together. Now, this is a problem that could really hurt when you're building multiple projects with this memory layer. For example, even if you're not using the same tech stack, let's say you build a to-do app, then later want to build another one, or any project with the same name, there's no clear way to separate those memories. At some point, one memory will cross into another, and that can break your whole project. That's one thing I feel should be added to this system. But overall, it's a really strong start, and I really love the direction it's going in. It works great if you're doing single projects or projects with very different names. It also depends on how Cursor executes queries and sends them. Usually you just write something like tech stack for this specific app, but in my case, the prompt was vague because I just wanted to test it. Other than that, it's a pretty solid tool and super useful. The concept is really impressive, and with just a bit more improvement, it could go a long way. That brings us to the end of this video. If you'd like to support the channel and help us keep making tutorials like this, you can do so by using the super thanks button below. As always, thank you for watching, and I'll see you in the next one.